Welcome to The Explainer. Today we're talking about microservices. You've probably heard the term, and for good reason. But getting it right, well, it's about more than just writing small bits of code. It's about having the right blueprint before you even start building.
So let's start with where many of us have lived, the monolith. You know the one. It's that single, gigantic, interconnected code base. The problem? You fix a tiny bug over here, and suddenly something completely unrelated breaks on the other side. It can be a nightmare. The modern alternative, of course, is the microservices architecture. The idea here is to break that one massive application into a bunch of smaller, truly independent services that can be built and deployed all on their own. But what really makes something a microservice? It's not just about size. It really boils down to three core principles. First off, each service has to be a totally self-contained unit, almost like its own little mini application. Second, each one is laser-focused on a single business capability, just billing or just appointments, nothing else. And third, and this is crucial, they're loosely coupled. They talk to each other, sure, but they don't have those rigid, brittle dependencies. Okay, so why all the hype? Well, this approach promises some seriously powerful benefits that get engineers really excited. Teams can work on their own pieces in parallel without constantly tripping over each other. You can scale just one part of your system, like the part that handles logins, without having to scale the whole thing. And maybe best of all, if one service goes down, it doesn't take the entire application down with it. But here's the thing. If you trace all of those amazing technical benefits back to their source, you land on something that isn't technical at all. It's about people. The single biggest, most important benefit you get from all of this is team autonomy. So what do we actually mean by team autonomy? It means you give a small team complete ownership over their service. They build it, they run it, they deploy it, they fix it, all without needing permission or waiting on a dozen other teams to get their work done. This independence, this freedom, is the real engine that makes all those other technical benefits possible. It's what lets you move fast. But this raises a huge question, right? How do you give all these different teams so much freedom without the whole thing just descending into absolute chaos? How do you make sure all these independent little pieces still come together to form a coherent, working system? Well, the answer lies in a really powerful design philosophy called domain-driven design, or DDD. The core idea is actually pretty simple. Instead of starting with the technology, you start by deeply, deeply understanding the business itself, the domain, as it's called. The whole goal is to create a software model that is a direct reflection of how the business actually works. Now, DDD is really broken into two phases. You can think of it like building a house. First, you've got strategic DDD. This is the architect's blueprint. It's the high-level planning where you figure out the what and the why. Then later comes tactical DDD. That's the actual construction, the code, the classes, the nitty-gritty how. For the rest of this explainer, we are focusing entirely on that strategic blueprint. To make this all feel a bit more concrete, let's walk through an example together. Let's pretend we're building a big, complex application for a hospital management system. The entire hospital, with all its moving parts, that's our domain. So the very first step in our strategic design is to look at this huge hospital domain and break it down into its main functional areas. We call these subdomains. So for our hospital, that would obviously be things like the clinical system for patient records, an appointment scheduling system, billing, pharmacy, and so on. And now we get to a really, really important step. We have to classify these subdomains. The core domain, that's your secret sauce. It's the thing that makes your business special. For our hospital, that's probably the clinical system. Then you have supporting domains, like billing. They're absolutely necessary, but they're not your competitive edge. And finally, generic domains are the solved problems, like user authentication, that you really shouldn't be reinventing. Why does this simple act of sorting things into buckets matter so much? Because it drives massive strategic decisions. It tells you where to put your absolute best engineers on the core domain always. It helps you decide what to build versus what you should just buy off the shelf, like for those generic domains. This makes sure your most valuable time and effort are spent where they'll have the biggest impact. Okay, so we've identified our subdomains. The very next step is to draw explicit boundaries around them. In DDD, we call this a bounded context. You can literally think of it as a protective wall that you build around a concept to make sure that inside that wall, a specific word has one and only one clear meaning. And this right here is the perfect example of why that is so incredibly important. Think about the word patient. To the appointment scheduling team, a patient is basically a name, a phone number, and a time slot.
But to the clinical team, a patient is a complex web of medical history, allergies, and diagnoses. They are not the same thing. And the bounded context is what protects these two very different meanings from colliding and causing all sorts of confusion. And to really enforce that clarity inside the wall, each bounded context develops what's called a ubiquitous language. It's just a fancy way of saying that everyone involved, the developers, the business experts, everyone, agrees to use a shared, precise vocabulary. So when someone inside the clinical context says patient, there is zero ambiguity. Everybody knows exactly what they're talking about. Okay, so we have all our independent, well-defined little worlds, but they still need to talk to each other, right? The final step in our strategic blueprint is to create a context map. Now, this isn't just a technical diagram of APIs. It's a map that defines the political and social relationships between the different teams. And that's what's so cool about a context map. It's really about team dynamics. For instance, you might define a customer-supplier relationship. That's a collaborative one, where one team can negotiate for changes from another. Or you might have a conformist relationship, which is more of a dictatorship. The downstream team just has to accept whatever the upstream team gives them, no questions asked. Defining these relationships up front saves so much pain later on. But what happens when your shiny new, clean service needs to talk to some old, messy legacy system? We've all been there. Well, that's when you can build what's called an anti-corruption layer. Just think of it like a universal translator. It sits in the middle and protects your beautiful new service from being corrupted by the messy design of the old one. It's a lifesaver. So let's just pull this all together. By following these 4 strategic steps, from understanding your domain, to classifying it, to drawing boundaries and mapping the relationships, you're doing way more than just designing software. You are creating an organizational blueprint, one that enables autonomy, focuses your best people on your biggest problems, and sets the entire project up for success before a single line of code is ever written. And that leaves us with one final thought. As you look at the systems you're building right now, ask yourself this. Do you see a clear, intentional blueprint that reflects the business? Or do you see what developers have famously called a big ball of mud, a giant, tangled mess where everything is connected to everything else with no clear boundaries? Because the answer to that question will probably determine how successful you're going to be.